Dear friends, welcome to this series of lectures on refrigeration and air conditioning. Today, I plan to discuss a very interesting topic, namely vapor absorption system. You'll find this very interesting and a bit of entertaining too. So let me write down this vapor absorption system. In one of our videos, I discussed about the conventional mode of refrigeration and its working principle, including the thermodynamic cycle. And that system was called as the vapor compression system. Okay. So this system which I am going to discuss is different from vapor compression system. Okay. And in order to understand how it is different, we need to reconsider the elements of vapor compression system. So if I want to list the elements of vapor compression system of VCR. VCR is a short form of vapor compression refrigeration system. So list of important components of vapor compression refrigeration system, you know that it has got an evaporator. Evaporator obviously has a function, an important role as a heat exchanger, wherein we get what is called as the cooling effect or refrigerating effect, right? The other important component is a compressor, and the job of the compressor, we understand, is to change the pressure difference, to maintain the pressure difference between the condenser, that is the suction, the discharge side, and the evaporator, that is the suction side. So compressor plays a vital role in maintaining the delta P, the role in maintaining the delta P. And why is the delta P important? The delta P means, by delta P, I mean the condenser pressure minus the evaporator pressure. Why is this delta P to be maintained? This delta P has to be maintained because we want to have the refrigerant boiling at the evaporator temperature, and the same refrigerant should boil the condense at the condensation temperature. So if you want to change the boiling point and the condensation point, then the only alternative for a given working fluid is to change the pressure. So compressor basically maintains different temperatures in the evaporator and condenser such that the refrigerant in the evaporator would evaporate and get you the cooling effect, and the refrigerant in the condenser would condense and reject the heat to the surroundings. So that is an important role of compressor, right? And the other part of the vapor compression refrigeration system is the condenser, wherein the heat is rejected to the surroundings. Okay, so this is another heat exchanger which rejects the heat to the surrounding. And finally, we have another important component, namely the expansion device. And this expansion device again plays the same role as that of the compressor, that is to maintain the pressure differential between the condenser pressure and the evaporator pressure. Okay, so delta P means it expands the refrigerant from the condenser pressure to the evaporator pressure. Now, this is the list of your conventional or vapor compression refrigeration system. In your vapor absorption system, compressor isn't used. Okay, so the distinguishing feature of the vapor absorption system is that it is a system without the compressor. Okay, so if there is some system without the compressor, obviously, and if it has to produce the refrigerating effect still, then we need to have some component or a set of components which would perform the same role as that of the compressor. Okay, so this way it is very easy to understand what is vapor absorption system. So what is vapor absorption system? Let me list down. Vapor absorption system is a system without the compressor. So what would be the components? Vapor absorption refrigeration system is a system without a compressor, but it would have the two heat exchangers. The same two heat exchangers, that is, it would have an evaporator. Then, as I said, that there is something which is in between, which would play the role of compressor, same function as that of the compressor. That something is to be written down here. Then you have a condenser, and you will have an expansion device. Okay. So figuring out what is the replacement of, so I will write down that this is the replacement of something replacing the compressor. Okay. So replacement of compressor is what? If you understand that, then you will understand what is a vapor absorption refrigeration system. Okay. So as I said, the compressor plays a vital role. And what is its role? The role of the compressor is to maintain the pressure differential between the evaporator and the condenser. Okay. So what is done in the absorption is, instead of compressor, you have three components. One is the absorber. The second is the pump. And the third is the desorber. So replacing the compressor, we have three components. One is the absorber, followed by a pump, followed by a desorber. You also have a name called as vapor generator instead of absorber. Okay. So generator has to mean vapor generator. So the components of vapor absorption system now would be, there would be evaporator, there would be an absorber, there would be a pump, there would be a desorber or vapor generator, then there is a condenser, and there is some expansion device. Okay. So these components in this order, these components in this order would play a role in giving you the refrigerating effect by executing a thermodynamic cycle. Okay. So let us now discuss how this cycle works. Okay. So I'll be now plotting a very simple block diagram to help you understand and appreciate this vapor absorption system. So what I would be drawing now is this block diagram of a vapor absorption system. So as I said, we'll have the same three components. The three components are similar to the compression refrigeration system. So let us say that this block would represent the high pressure side heat exchanger, namely the condenser. This block represents, let us say, the low pressure heat exchanger, namely the evaporator. Evaporator. And then there is some expansion device over here. Let us say this is your expansion device. Okay. So the refrigerant from the condenser would go into the expansion device. And from the expansion device, this refrigerant would get back to the evaporator. So this is similar to the vapor compression refrigeration system. This portion which I have drawn is similar to the vapor compression refrigeration system. Okay, now what next? Okay, as I said that we will not have a compressor here, but instead of compressor, you will have three components. So let me list down these three components. So one is so before that, okay, before that, let me talk about the pressures and the phases. So condenser obviously is at high pressure and the refrigerant is liquid, right? Condenser means it is a high pressure liquid refrigerant because it is already condensed, okay? And it is condensed because of heat rejected by the condenser. Heat is rejected by the condenser, okay? This, after the expansion device, we would have a low pressure refrigerant. Low pressure refrigerant, which is mostly liquid, entering the evaporator. Okay, mostly liquid entering the evaporator. Now, what you expect in the evaporator is the evaporator would absorb the heat from the space to be cooled. Suppose this is a space to be cooled. Okay, this is a space to be cooled from which the heat is to be rejected and taken to the evaporator. So let us say QL, right? And as a result of which the refrigerant would boil, it would evaporate. And what you are expecting here is low pressure gas refrigerant. Okay, it is not the liquid now, it is a gas refrigerant because it is converted to gaseous state. Okay, so gaseous refrigerant, or it is, you can use the term vapor also, right? But it is mostly, it is not a vapor in the sense that it does not have any liquid. So it is a gas refrigerant which is at a low pressure. Okay, now as I said, in the condenser, what you expect is, let me just pull this here. In the condenser, you are expecting that a gas should enter, okay? Because before condensation, condensation means you are converting the gas to liquid, okay? So the pressure is high pressure, and what should enter is the gas which should condense, okay? The gas means the vapor which should condense, okay? So this is similar to this, whatever I had drawn here is similar to your vapor compression refrigeration system. Now, instead of the refrigerant going to the compressor, mind well that when you are talking about vapor compression system, if you remember it correctly, this low pressure gas refrigerant would enter the compressor. Now, it will not enter the compressor. It will instead enter what is known as the absorber. Okay. So the refrigerant enters what is known as the absorber. So let me write down that this is an absorber. Okay. We will not study now as to what exactly is this absorber. What are the fluids which are used as absorber? Okay, that we'll see later. So from a conceptual angle now, try to figure out that this liquid refrigerant, this gaseous refrigerant which is at low pressure would enter the absorber and then convert itself to a solution, because you know that means the liquid in a way. Solution, it means it is a liquid. It was earlier a gas. Now there is an absorbent in the absorber. The absorbent would absorb this gas. Absorbent would absorb. There is an absorbent here. This absorbent plus gas would give you a solution. Okay. This liquid solution would then enter the solution pump. It would then enter what is called as a pump, liquid pump, a solution pump. Okay. And as a result of which the pressure would increase. So this was the low pressure solution, and because it is now pumped, so what you are expecting is a high pressure solution. High pressure solution. The solution is of refrigerant and absorbent. Okay, the refrigerant gas and the absorbent solution is there. Now what is happening next is it goes to another heat exchanger, which is called as the desorber. Okay, so let me write down this desorber. Desorber, or it's also called as the vapor generator. Vapor generator. And then what happens is in the desorber, desorber is just the opposite of absorber, wherein the gas, the refrigerant gas is liberated. Refrigerant gas is liberated, okay, and this refrigerant gas would then enter the condenser. So this way it goes into the condenser. And the solution which is left, which would have now a lower concentration of gas. Okay, so this would have a higher concentration of gas, higher concentration of gas, and this would have a lower concentration of gas because gas mostly is liberated. This would then be expanded back to the, this would be expanded back to the absorber. Okay, so this is mostly absorbent, but it is actually a solution with some gas, returning back to the absorber, Okay, now in order to achieve this liberation of the gas, we need to supply a certain quantity of external energy, and this external energy is in the form of heat. So let me call this as QG. So QG is, to me now, QG is the heat supplied to the vapor generator or degenerator, okay, to desorber. Heat supplied to the desorber is, or generator is, QG, okay. And when there is an absorption process, it's chemical process, it is an exothermic process, so certain heat is rejected. So let us say QA is rejected by the absorber, okay. So this completes, and for running this pump, obviously you need to supply certain work, okay, you need to supply certain work. So look at this now. Look at this system now. What is happening here? The space is to be cooled. So the heat is to be absorbed by the evaporator. For the heat to be absorbed by the evaporator, the heat has to be flown through a delta T. So this evaporator would be at a low temperature, okay, and the space has to be maintained at a temperature which is much lower, right? So that there has to be some delta T. Without this delta T, so this is much lower than the temperature of the evaporator. As a result of which, the heat would flow from the low temperature to a relatively high temperature, okay. This heat which is removed is known as the refrigerating effect. This is the cooling effect or refrigerating effect. As a result of which, the refrigerant gets converted to gaseous form, and this gaseous form of refrigerant, which is at low pressure, enters the absorber. In the absorber, it is bubbled into the absorber, and the gas gets absorbed by the absorbent. Okay, when the refrigerant gas gets absorbed by the absorbent, what we get is a solution. This low pressure solution is pumped to a high pressure solution by using the electricity supplied to the pump. So what you get is, now you get a high pressure solution because of supply of electrical energy or high grade energy, that is the work, to the pump. This high pressure solution has higher form of refrigerant. The refrigerant is more as compared to this low pressure solution. This high pressure solution of the refrigerant enters the desorber section or vapor generator section. There are two names, again I am repeating this. One is the desorber, opposite of absorption, or it is called as a vapor generator because vapors are being generated. Refrigerant vapors are liberated. The gas is liberated in the desorber. And why is that happening? That is happening because you need to supply some external heat to the desorber, as a result of which this gas would separate out, it will boil out and get into the condenser. Okay, so the refrigerant gas would get into the condenser. What is left is the solution which is having less gas. Okay, less gas, and this gas and the solution would then be expanded back to the absorber pressure. Okay, so you need to understand that absorber is at lower pressure, and theoretically this absorber is at a pressure of the evaporator. This desorber is at a pressure of the condenser, right? And this delta P, the pressure difference between the absorber, the high pressure side and the low pressure side. This is the low pressure side. This entire side is a low pressure side involving absorber and evaporator. And this condenser and desorber is a high pressure side. So this pressure differential is maintained by the pump and the expansion valve. So what is the advantage of this system over the compression system? So you see over here that this system is heat driven system. It is a heat driven. The major source of energy to this refrigeration system is the heat which is supplied to the generator. Okay, there is some electricity used, but mostly it is the input to the system is heat, and what you get is heat driven. What you get is cooling effect. So this is interesting. You know that you are heating something and you are getting a refrigerating effect. Okay, so refrigerating effect is obtained because of the supply of heat. This is very interesting. Can you imagine this? That you are supplying heat and still you are getting cooling effect. If you are asked, if you are not studied the system, and if I had asked you this question, that is it possible to get a cooling effect, a refrigerating effect by supplying heat? You would say, no, it would create heating effect, not a cooling effect. But look at this system. This is a very interesting system, vapor absorption system, where you are getting a cooling effect, a refrigerating effect by supplying the heat. Okay, and this system has been possible because of the incorporation of three components which would replace the compressor. These three components are absorber, desorber, and a pump. Okay, this system, when you are talking about a refrigeration system, you should always talk about two important solutions. One is the refrigerant, obviously. So the working fluid of your vapor absorption system, one is that refrigerant, okay, which participates in the refrigerating effect. So the fluid which is entering the evaporator is the refrigerant. Okay, and another important fluid without which the system will not function is the absorbent. Okay, and depending upon, this is a pair, okay, absorbent. Okay, so depending upon which is the refrigerant, which is absorbent, you will have different types of vapor absorption system. So one very popular system is wherein you are using ammonia as the refrigerant and you are using water as the absorbent. So this is one important pair which is going to give you the cooling effect in the vapor absorption system. Another equally important refrigerant system, okay, vapor absorption system, is a water lithium bromide. So water is the refrigerant. Mind well, water is the refrigerant here. In this case, water is the absorbent. So in the ammonia water system, ammonia is the refrigerant and water is the absorbent. In the LIBR, this is lithium bromide solution, lithium bromide salt solution. Lithium bromide salt solution is the absorbent and water is the refrigerant. Okay, look at this. This is very interesting. In this case, you'll have water as the refrigerant, and in this case, you will have ammonia as a refrigerant. Okay, so these two important pairs you should remember at least. There are others also, but LIBR, water system, and ammonia water system. These are two commercially available vapor absorption systems in the market. Okay, this is very interesting. Now, when to use this system, when to use this system? So, ammonia water vapor absorption system is used when your refrigerating effect is to be obtained at negative temperatures. Okay. And this is always used when you are talking about positive temperatures, means above zero. The reason is simple, because here the water is used as the refrigerant, and you know that the freezing point of water is 0 degrees centigrade. So this has to be used above 0 degrees centigrade. Whereas here you can achieve lower than 0 temperatures by using this ammonia water system. Lower than 0 temperatures are achievable. Okay. It means that if you are looking for an applications like cold storages, freezers, and other refrigeration systems, then ammonia water system is the way to go. And if you are looking for air conditioning applications, AC applications, then in that case we use the lithium water system as a absorbent refrigerant pair. Okay, so this we need to be very clear, right? Now, how do you assess the performance of this system? How do you calculate the performance of the system? So performance of this system is calculated by the expression called as coefficient of performance, COP. Coefficient of performance of the system is the desired effect. Now, what is the desired effect? So the desired effect is QL. Okay. The desired effect is the refrigerating effect. So how much refrigerating effect one gets from this system, and for that, how much heat is to be supplied, that gives you the coefficient of performance of vapor absorption machine. Okay. Coefficient of performance of vapor absorption system is QL upon QG, or if you want to also incorporate the pump work, then the refrigerating effect, that is the desired effect, is QL, and the input is not only the heat supplied to the generator, but also some small amount of electricity being supplied via the pump. Okay, so that is more appropriate expression. But as you see, if you compare this with the COP of vapor compression system expression, what will be clear to you that vapor compression refrigeration system, it is QL upon compressor work. Okay, so what is the difference between subtle difference, a very important difference between a vapor absorption system and vapor compression system is vapor absorption system is a heat driven system, and one can use waste heat like say the heat from the exhaust gases of the engine, or one can use renewable heat like say the energy from the sun. Okay. The QG is heat driven. So wherever there is a possibility of harnessing waste heat energy, waste heat recovery, there one can use this vapor absorption system. Okay. Vapor absorption systems are very huge in capacities. If you do a market survey, you'll find that they come in tons. They are specified in tons of refrigeration, many tons. Okay. So smaller systems are there, but mostly commercially viable systems are in larger tonnages. Whereas in your vapor compression systems, you have very small systems and very large systems. Wide range of systems are available for vapor compression applications. Okay. So I hope that this has given you a good understanding of what is a vapor absorption system and how it is different from vapor compression systems. Right. Let us stop here, and whatever queries you have, we will always answer them. Right. If you have any queries, you please type them in the questions column. Have a good day. Bye for now. Thank you.